Right, grand. Sorry about that. So the functional versus non-functional testing. I'm going to just go through this very quickly. And if anybody has, if I'm skipping something too quick, just shout, okay? So again, we're looking at the two main areas of focus in terms of functional and non-functional requirements. So non-functional really is how well does the system does something, okay? So this is really part of the stuff that comes in with web testing, because the system could well be performing the task, but it's doing it very slowly, okay? Or the system does what it's supposed to do if you know that you're supposed to press two buttons at the same time and shake your head twice or whatever. So there's some kind of non intuitive way of doing something. Okay. Functional testing then is just confirming to the system's functions as it should. So that's, I don't mean it's a given, because that's one of the things we do with testing, but we kind of look at two things. It's not just about it doing it correctly, but it's doing it well, if you like. So that's sort of the difference between the two. So the test types can include browser compatibility testing. So yeah, this works great in Chrome, but if you try it in Edge, it doesn't work at all. Maintainability testing. So yeah, it works grand today, but I want to add stuff to it in the future, and it becomes a right mess altogether. Portability testing, if we're moving it across different platforms, so it might work okay on a Mac, but it doesn't work on a Windows machine or whatever. Accessibility testing then really is looking at stuff like, can every type of user use it? Okay, so if somebody is obviously visual impaired, impairment is a big one that comes into this. There's also audible issues. It was interesting actually yesterday when I was mentioning that about the radio programs. One of the issues that came up was with people who have a hearing issue, and they were finding that online delivery was just totally wasn't working at all. Okay, so and you could imagine in a situation like this, what you're seeing on the screen there now, and you're hearing me talking. But if somebody was able to perform, say, lip reading, they wouldn't be able to see me properly to be able to do that. So that's accessibility type testing we need to do. Usability testing, and that's is it usable? Like it's okay, everything's grand, it works, but it's too much bother to use. Okay. Then we mentioned the other day load stress performance testing. So that's okay. It works grand with one user. What happens if it's 5 users? What happens if it's a case that the user happens to be in Australia and they're using the site and it's hosted in Europe, for example? Okay. And then security testing, again, that's looking at, right, okay, everything's working grand, but what if somebody wants to hack the system or break into it or mess it up? Okay. And functional testing types then look at component unit testing, integration testing, system testing, and acceptance testing. But from an overall point of view, we need to look at both of these areas. And there's this kind of mapping between the two. And I guess on the bottom axis, you have this whole project management. How do you manage this whole aspect of, particularly with functional testing? So the user specifications and acceptance testings, but bearing in mind the user specifications are sort of old world in terms of there's more to do with the kind of the waterfall approach. When we look at pure agile software development, user specifications may actually not be written down anywhere. Okay, particularly if you're in an in-house organization where the documentation mightn't follow the level of agility that's in the whole development, and you'll find that a lot, particularly with startup organizations where everybody's jumping into different directions all over the place. Okay, so it's one of the things we need to look at it. Component testing, individual units of code. Most often it's done with unit testing. Oops. But it could also be called modular or program testing, because somebody's unit today, if you're writing a method for an object, you're in a unit testing, and that's what you think your individual unit of code. If you're actually taking in a class or an object that somebody else has created, you at your level of programming might be thinking of that whole class as being a unit. So it does kind of change what we think of in terms of what a component actually is. So we write these unit tests to find and fix defaults into our code. It's done as early as possible in the development process. Early testing is critical. in agile development environments where short release cycles require fast test feedback. So typically one of the things with agile we try to see, or we normally see, is that code is developed very quickly and it is then presented to the next stage very quickly as well. So you can't, when you're in the second sprint, you don't necessarily be wanting to go back and fix problems that would have occurred in the first sprint. Normally what happens in most organizations that are using agile and are using software testing, they will have testing input to give that approval to move from sprint 1 to sprint 2. So it's kind of part of the deliverables in it. Unit tests are white box testing because they're written with a knowledge of the code being checked. So remember this thing of white box and black box. So black box is sort of, I don't really know what's inside there, but I know if I do this, I get this response from it. Whereas white box is you're actually inside the box. You have clarity and visibility of all the code. And you know what's going on. Integration testing combines individual tests and tests the interaction. So common type of integration test is interface and API tests. And so kind of moving on from what we've done last semester with the web services and that, your web services essentially your API testing. So there would have been a documentation on the API that if I send this particular keyword and this particular, say if we're using JWT API key, then I will get a particular response. So you can actually test that. Interface testing is when we sort of, if we go back to when we were using MVC in second year, the interface testing would be checking to see, if you like, that your functions for in the model, that they actually work. So you might have like a interface between, if you like, your controller and the model, which would be the function calls as such. API rules tend to be very stable in any given application. Their API tests are a good candidate for automation, and that's very true. Normally, even within an organization, you'll sometimes create code which is, it might be legacy code. That the application is being enhanced. So you have this code that it works, it's tested, it is known to be good, and there's well-defined interfaces to it. So I know if I provide X inputs, I will get Y output, and I don't need to test, the library functions, if you like. Okay, so interacting with those is very good for automation. So this interface API tests are also white box tests because they require knowledge of the code being checked. It might not be, if you like, a complete white box test because you only know what the interface is and what the output is. You don't necessarily know what the code inside the API is, but you do know what the code is on the interface, and you're testing that interface. And that's the integration. So you have, if you like, a block of code, 2 blocks of code, and one of them is interfaced with the other. One block of code, if you like, has been fully tested and is okay. You're just checking to see how you're able to communicate with it. And then the system testing verifies that complete integrated system is working as designed. No knowledge of the underlying code is necessary. This is pure black box testing, because essentially what happened was the client or the customer has come and said, I need a system that does this, 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 and this. The company or yourself have actually gone and integrated that, developed all the code, have it all working. The system testing is when the system, and sort of user testing as well, comes in and goes, I want to do this, 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 and this. Does it work? Yes, it does. No, it doesn't. Okay. So system test is level where front end, the GUI and the web testing occurs. And that's a very important level for us because there's a lot of, and there can be a lot of subtlety in that when it comes to websites. Because with web testing, we may be using different colors, we may be using different pieces of text, we'll have different types of users coming in complex systems. There's a whole range of fluidness that's actually shown on the screen itself, and sometimes it's how we view the screen is very, very important. The examples being, some of the quoted examples in the past would be, and some that I've actually worked on, where we actually developed a system And the difference was that this was replacing an existing software system. The people that were actually working the system, the actual end users themselves, were all very, very skilled typists. So they didn't actually look at the screen. To be honest with you, they just typed. So they would have maybe a piece of paper that had the information that they had to enter into the system, and they were literally just looking at it and typing away. So they weren't seeing what was on the screen. And for some, and this is where design comes in, but as well as testing, what was actually happening was they were, rather than filling in forms kind of top to bottom, they had their knowledge and the information that they were reading from. The information was actually going left to right and up to down. So the whole tab order was completely different. So that the big problems occurred when I started typing, because normally when we fill a form, our tab order is going top to bottom. But these guys wanted the tab order to be going kind of left to right, which caused great great rework and concern. But again, you have two options there. Do you retrain your workforce, and the customer is going to say no? You design your system properly. So that's where system testing will capture a lot of these things, and that's where testers typically come into their own, and test designers to be able to understand these differences that are required. Acceptance tests, and so this is the end users and the end user proxies, or the product owners, or whatever. So this is where you actually find out whether or not, and a lot of this is very much non-functional, because the user is used to doing this a certain way. Okay, and you can mess things up by, if you have a something out of order on a screen, it just goes crazy. Okay, the goal of user acceptance tests and URT is to ensure that the application solves the customer's need. I would even take it further. I would say the goal of user acceptance testing is to actually get paid. Okay, it is that important. You will have customers who will refuse to pay that final amount until the UAT is done to their satisfaction. Okay, so it's a very important bit. And a lot of that is non-functional, because the expectation is that the functional stuff, the uh, adding two numbers up correctly, or the root stuff there is being done. This is at a higher level there, and you're actually testing the complete system. Okay. The test techniques that we use are different for all of these, Dan. So each individual technique is good at finding particular types of defects and poor at finding other types. Unit testing will not find some kind of difference in that this isn't in the right tab order or whatever. Okay. In the same way that entering in data doesn't necessarily mean that it's been entered correctly. So designing your tests and designing it with a view of what test techniques you can use, and what test techniques are appropriate is very important. Because remember, we don't want to be retesting stuff all the time, but we also want to be able to find bugs in the system at as early a stage in the development cycle as possible, because it's cheaper to fix them then, and it takes less time. Okay. So typically tests performed at different stages in the life cycle will find different types of defects. So component testing is more likely to find coding logic defects than system design defects. You'll typically find that, if we take something at a very low level, like say checking a user for login, we can have very specific checks for that. Okay. Now, that can be handled, if you like, very easily with the unit tests. There's not an awful lot of design that would need to go into that. Now, if you, on the other hand, you want to check to see if a specific user is able to perform a certain function because of their user type, that becomes a lot more complex. Okay, so you'd have different stages for doing that. Test techniques would typically fall into two main categories: static, the code does not run as part of the test, and dynamic, where the code executes as part of the test. So our dynamic testing is divided into three subcategories: black box, white box, and experience-based. Okay. Black box, again, this is just revision. You've all know this, I'm sure. View the software as a black box with inputs and outputs. So there's absolutely no knowledge of what's on the inside. Okay. Just data in, data out. Okay. Testers concentrate on what the software does, not how it does it. So if you know that you've got two inputs and you've got one type of output, it's very easy to determine then, right, if we've got two inputs, I could have, if you like, 4 possible combinations, and therefore I can get outputs based on those. So it could be if I've got a username and a password. If the username and the password are correct, I get an output which is, say, true. If it's something like check login or something, okay? If I've got a username that exists but the password is incorrect, I should get a false. If I've got a username that's false but the password exists, I should get a false. If I have a username that doesn't exist and a password that doesn't exist, I should get a false. I should only get a true when the username and the password are correct and are matched with each other. Okay, so that's how the whole sequence of the different strategies that Jerry would have gone through with you last semester, was all based on this idea of how do you actually get the optimum situation. Okay, now when you're down at unit testing, you may well want to test all 4 criteria. But when you're at the higher level, you might want to say, well, I'm going to test with a good user and a bad user, okay? Because you kind of have this confidence that the other, there's no benefit really in trying to log into a system with a bad password and a bad username, if that's already been tested at a very low level to know that it doesn't work, okay? So these are decisions and confidence that you have in the whole testing plan and the design of the whole test system that's been done. Black box techniques are used for both functional and non-functional testing. So we could well use it for non-functional or for functional testing. Now, specification-based, aka black box techniques. So we've got the main black box techniques: equivalent partitioning, boundary value analysis, decision tables, and state transition testing. And I'm sure you all remember them with Lee from software testing previously. Okay. And it might be no harm for you to do a quick revision on some of that, because we will be using some of those techniques. First 2 techniques, equivalence partitioning and boundary value analysis, are closely related. So these are going to be covered together, but not on this as we know it. Okay. So that's a quick run through on the functional versus non-functional. The next one here is revising test case development. Firstly, I presume there's no questions on that functional versus non-functional testing. Everybody okay?
No.
Good. So I'm just going to go through this revising test case development. And we look at this. Now, this is something that we will be doing a lot, and we'll actually be using that today in our tutorial. And what we're looking at here is, before executing tests, we need to establish what behavior we're actually attempting to test, what inputs to use, what the results should be produced by those inputs, and how the test should be run. So if there's any sequences or whatever, okay? So it doesn't matter what type of system we're doing. We're doing this for a web, okay? So the focus is on web testing. But essentially it doesn't really matter, because we should know that if we are going to test something, we should know, well, what inputs can we use and what's the expected result, right? We don't go and say, right, I'm going to try 1 and 7 and get an answer and say, now I wonder is that answer right or not, and then try and work our way towards that. No, that won't work. We should have, if the inputs are 1 and 7, we should know exactly what the output is, okay, or the expected output is, and then we can check to see if the actual output matches the expected output. Now, when you hear it like that, you say, yeah, logical, no problem. I just want you to remember that statement for all those times when you're there and you're doing a test and you realize, I wonder what the right answer is here, okay? Because we all run at that, okay? The other thing is, if there's any kind of an order in how things should be run, right? Instead of, is there any like preconditions? For example, like, do I need to be logged in before I can actually do this test? Okay. Do I need to be registered before I can log in? So there's a sequence of things need to be done there, right? How as well do you need to consider that if a test fails and you're going to start it all over again, Is there a set of preconditions that need to be there? For example, let's say you are testing a system where you register and then you log in. So you register, okay, then you go to log in and it fails for some reason, okay? Somebody goes and fixes that. Where does your test start again? Where do you have to go and say, well, I need to register again and then log in, or can I just try logging in with the user that I've already registered? Okay. Now, the answer to that really depends on, to a certain extent, where the problem was, right? And how the problem was fixed. Let's say, for example, we'll just take something simple where you've got your registration is an email address and a password, okay? And then your login is going to check the register or the email address and the password, and it was okay, you get logged in. So it's fairly standard, straight enough stuff. But what if the problem is in the registration? That when you actually saved the um, the email address and password, you didn't save it correctly, right? That means then that if you want to check the thing again, check the features again, you need to actually go and register again, because obviously if your first user that you entered in wasn't registered correctly or wasn't saved in the database correctly. Alternatively, it could have been that there was a problem in the actual check login process, right? So in that case, what could happen is you could say, well, actually the registration was okay, so we just need to do the check login test again. So these are preconditions that may or may not be fluid or may change. If you're doing this yourself, okay, you'll probably say, right, well, I know now I just have to go and check. I'll need to re-register again, and bump, and you do it, okay? However, bear in mind, a lot of this stuff that's happening in larger organizations is happening in not maybe even different departments, at least maybe different individuals being involved in it. So what's going to happen is somebody is going to test your login options. It's going to fail. They're going to send the whole thing back. And when it comes back out again, they're going to repeat the same test. Okay. So that test needs to be kind of very well predefined. Okay. And that's where these preconditions come in. And when we're actually thinking of what tests we're going to run and what our test development process actually is, we have to take all that into account. And we have to be very kind of devil's advocate as such that we're, really and truly we're there thinking to ourselves, right, I'm going to try and break the system here. Okay. We can't test everything. It's too impractical. Okay. So you have to develop a subset of test cases that, and the question, hopefully there hit all possible problems. You want to make sure, if we take that simple case with logging in, you want to make sure that the only people that can log in are those that are allowed to log in. Okay. Now, sometimes you'll look at the code and you will determine that. Okay. Sometimes if you're doing black box testing, you have to actually test an awful lot because you don't have confidence. You don't know what's actually in the code. What's the balance? That's the difference between a good tester and a bad one. And there's no real answer on that. That's just experience comes into play. Right. Specifying test cases. Okay. Test cases must have input values. Okay. Even if those input values are 0. Right. And a test case has to have expected results or outputs, right, for the specified inputs. So what we're looking at here is a situation of how do we actually define, and in some cases we'll have situations where we think, well, actually, I can't see if there's an input there, right? Let's take an example where we've got different types of users. And we, depending on your user type, will determine the dashboard that you're going to see when you log in. How do you check that for different users? Okay, so we have to ponder that. If you've got 10 different users, then does that mean we have 10 different tests? Now, some of this is going to depend on how the code is put together. So, like good test development and good specification of test cases. Actually, if you know the code and how the code is being developed, can help you with all of that. Okay, it's more difficult if it's totally black box. Okay. So in order to know what the system should do, we need to have a source of information that it's about its correct behavior. Okay. Now, typically, that's the requirement specification document. But as we all know, they are sometimes a bit like hen's teeth. They're not very common. So we have to sometimes dig quite a lot to get the requirement specification document. And in a lot of cases, this will involve interviews with users and with developers. Okay, so there's a lot of work has to go into that. Once a given input value has been chosen, the tester needs to determine what the expected result of entering that input would be and document it as part of the test case. With websites and with web applications, there's an added problem here in that sometimes that's just not plain sailing, okay? Because we've got different scenarios in terms of what. Let's even take something simple like what screen size you're looking at, okay? What device you're on. The test result could be different if I'm looking, if there's, say, if we're using responsive design and there are different devices, like say the web, uh, tablet, and mobile smartphone. Um, the expected result we sometimes need to describe it rather than be very specific because it may not be on a specific part of the screen that you will get this output changing. Okay, the color might change in on a desktop. There might be a subtle different way of doing it on a tablet. We might use a mouse on a desktop. Obviously, we can't necessarily use a mouse event on a tablet. So these are all issues that we need to be able to check. If somebody has designed their software to work on a right click and you're looking at it on a tablet, how do you check for that? Okay. The expected results should be predicted before the test is run, could include information displayed on the screen in response to an input, changes to data or to states, or any other consequence of a test letter to be printed, and where it's been printed, because when it comes into web stuff, we've got that whole doing stuff on a testing on, say, a Java application, desktop application. It's fairly straightforward because it's there's nothing really changes on it. But in our case, it does, and quite significantly. Now, this is kind of important for today. Our test case structure. We'll have the test case ID, which is used for cross-referencing with other documentation. So essentially, this just means we have a number. There's no point in me as a tester going back to the development team and saying, okay, test case 27 failed. If that isn't a unique and well recognized test case, because the developer could be there saying, what do you mean test case 27? I never heard of that one. And you say, well, it's a thing to do with the login. Oh, okay, right, yeah, right, I can sort that out. So we have some kind of an ID. Different organizations have different structures for doing this. Some get very, very impressive with their naming structures, and there's all sorts of alphanumeric systems put together for it. Okay, but that's partly one of the in a organization, and to intents and purposes for our assessments this semester, you guys are going to be that organization. You need to actually decide what your test case ID referencing is going to be. Now, so again, this is just some means of, and there's no prescribed way of doing this, some means of being able to identify a specific test. It will have some kind of a title, but the test case is what's actually used in terms of documentation and processing and everything. So if we're looking at getting from sprint 1 to sprint 2, there will be a series of test cases that have to be passed, and each of those will have an ID. Okay. There'll be a title then, which could be a short title of what it is for lay people, like check registration. There could be a description then, which is a short description of what the test is assessing. There'll be preconditions, so any conditions have to be fulfilled before the test can be run. So that could be something like user must be registered correctly or something like that. There's any assumptions that the test is relying on. It's a little bit like a prerequisite or a precondition, but it can be different. Like the assumption here could be that the user is using Chrome, okay, as their browser. That may not be put in as a precondition because you're getting into too much of a level of detail. But that assumption is normally put out there because you might well decide as a test and strategy, okay, guys, we're going to get this working in Chrome, and then we'll repeat the test later on, working in Edge and working on Firefox and any of the other browsers that we need to work with, okay? Or you might have it, okay, we're going to be testing initially on Macs rather than on Windows machines, okay? So that detail wouldn't necessarily need to be in each individual test case as a condition, right? It's a precondition, but it would be an assumption. You'll then have input or inputs, you then have test steps, and then you have expected results, okay? So I put in an input email, and I put an input password, and I click login, and it should log me in, okay? So that's the idea here. And we document all of that. Okay, right, so that's a quick return to all of that. Now, this is some interesting stuff now that we're going to try doing, and there's a link here which brings up this here. It asks you to read an article at riceconsulting.com. I don't know exactly who these guys are, but obviously they do a lot of information with regard to web testing and so forth. So it's useful enough to look at them. This is their test case here, Rice Consulting. So they've got some free resources. They've got some interesting resources there, and you'll find there's an awful lot of resources around for the web. Okay. Now this case here, we look at this case now in a wee second. The going to use the business rule below, working in groups to document the test case to test this feature. Now, at this point, I'd consider using a spreadsheet or word processor. There's some collaborative tools you could use within Teams that would work out for this. Your whiteboard and that, when I put you into groups, that should work out all right. You should employ your knowledge from last year's software testing module along with what we've just gone through there to determine the test cases. Now, what's happening here is we're changing the business rule, okay? So a customer may select one of several options for shipping and ordering online, blah, 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 okay? And then what you need to do is create a test case to fully check out the business rule. So let's have a look at what they're looking at here. So how to develop test case and test scripts for web testing. Now, I'm not going to read through all of this, but we're going to put you in groups. I want you to go through it yourself. Some interesting stuff there. And again, a lot of it is just will be reviewing, if you like, what we've looked at. So looks at ID, looks at condition, looks at expected results, looks at procedure, pass, fail, defect number, cross-reference. And this is the simple business rule that they have, okay? So what they actually do then is the table shows the shipping options of an e-commerce application, right? So this essentially is developing the test case here. So test ID 1, what's the test condition? Customer orders products totaling less than $20 and selects overnight shipping. Shipping charge of $12 is applied. Procedure, customer assesses secure ordering page. Customer adds item. Customer selects overnight shipping. Customer delivers items in the shipping cart, blah, blah. And you've got pass, fail, and a defect ID is coming out here. Okay. So that's sort of the general idea of a process you would use to do this. Test designer does not specify one copy of Gone with the Wind paperback. So there's other bits and pieces there to read it. Okay. There's no sequence. The order of the columns is up to you, right? Your test case design strategies for web applications. Nature of the intended users. Need to repeat the test. Level of relative risk. Degree of change. Test scripts you can put together for it. Web pages are visually orientated and strive to deliver the same type of flexibility as a client-server GUI. So this is what we're looking at here, some extra pieces that may be there. So these again are all questions that we need to ask, and again, encourage you to read into this. Okay. So the task will be, so again, to kind of look through this. And then you want to put that into here where there's going to be a different business rule. Okay. So what essentially you'll need to do is you'll need to develop roughly, right, a table that looks like this. Okay. And put in then the different inputs you're going to use. Okay. So you'll need to do a little bit of your, getting your notes out from last year. You got the different type of uh, where is that? Yeah, this type of stuff here. So you've got your equivalence partitioning, your boundary value analysis, decision tables, and static transition testing. Okay. So I'd like you to, and as I said, this is what we'll do in the lab. I'd like you to consider all of that in trying to implement this business rule here. Okay. And from that to develop a series of testing procedures, if you like, or the order. So your actual test cases are being put together. So how many test cases you need to get, what kind of details are there. Now you can put as much detail in here. I know a lot of times, sometimes what will tend to happen is we might have a couple of extra columns there, which would include such things as having the inputs that are required, and specifying that a little piece more. Okay.